Welcome to this series. In this series, we are going to look at moment. Now, moment is sometimes referred to as torque, T-O-R-Q-U-E. Now, what is torque? It is a measure of the tendency of a force to rotate an object about an axis or a pivot point. So, if you have, let's say, the hinge of a door, when you toss the door back and forth, there is a fixed point that rotates. Now, the measure of the tendency of the force to rotate the door is termed as torque. Now, torque depends on two things. It depends on the strength of the force and the distance. So this leads us to the formula for moment or torque. It is the force multiplied by distance. The force of 10 Newton is applied 2 meters from the pivot. Calculate the moment of the force. Now, before we look at the calculation, let's try to figure out the unit for torque. The unit for force is Newton multiplied by the unit for distance. Standard unit is meters. So Newton meter. So after doing your calculation, you have Newton meter by your figure or whatever you are calculating for. So the force over here is 10 Newton. So 10 multiplied by the distance 2 meters. So you are going to have 20. So 20 Newton meter. A spanner applies a force of 20 Newton at a distance of 0.5 meters from a bolt. What is the moment? As I've already explained, moment is a measure of the tendency of a force to rotate an object over here, and the object over here is the spanner trying to turn the bolt back and forth. So we state our formula for moment. Moment equals the force times your distance. The force here is 20 Newton. Your distance is 0.5 meters. So after doing your calculation very well, you are going to have 10 Newton meter. The next question. A beam is balanced by 50 Newton force at 3 meters on one side. What force is required at 4 meters on the other side of the balance? Now think of a balance this way. Just use the simple rod to be our balance. So it's balanced by a force of 50 Newton on one side. Now if it's a balance, definitely you should have a turning point, which is the pivot. Now there's a force of 50 Newton on the left side balancing the beam, and there's this force as well balancing at the other side of the beam. So this force is what we don't know. Now there are some conditions that must be met for the beam to be balanced. This is a general rule for moment, solving questions in moment. So the sum of clockwise moment must be equal to the sum of anticlockwise moment. What does this mean? So let me just do this to represent the way a clock works. In this direction, we call it clockwise moment because this is the direction in which the the little arms on the clock moves. Now, in this direction is the anticlockwise. Anticlockwise means the opposite direction of the arms on the clock. So on this beam, which one will we call anticlockwise? Which one do we call anticlockwise? So on the right side, this is the clockwise. So clockwise moment equals a certain force we don't know multiplied by the distance, which is 4 meters. So the clockwise moment will give us 4F. Now anticlockwise moment, which I'll use ACW, 50 multiplied by 3. We have 150 Newton meter. Now, according to the condition, the sum of clockwise moment should be equal to sum of anticlockwise moment. So we are going to have the clockwise 4F equals anti-clockwise moment 150. So divide both sides by 4. So 150 divided by 4. Our answer is 37.5 Newton. That is our answer. A seesaw is balanced with a 40 Newton weight at 2 meters on its side. So 40 Newton at 2 meters. So a seesaw is balanced with 40 Newton weight at 2 meters on one side and 50 Newton weight at the other side. Find the distance. So this distance, let's represent with n. Let me not use n because you already have n there. Let me use y. So our clockwise moment, we have 50 multiplied by y. I was thinking through it. This is how the clock moves. This is the anti-clockwise moment. So anti-clockwise moment, we have A, C, W. We have 40 multiplied by 2. Clockwise moment equals anti-clockwise. So we are going to have 50y equals 80. Divide both sides by 50 over 50 over 50. We are going to have y equals 1.6 meters. So this weight is supposed to be 1.6 meters away from the center.